Alright, welcome to the very first video of the school year in Algebra 1. We're going to start with the section right before Chapter 1. This is 0.2. And we're just going to go over some definitions right now, which deal with certain number sets. You can see on here, I already have the definitions on the video right now, which you can start taking down. And you can start taking that down on the note packet that you have, and we'll go over it one by one. Okay, first one's real numbers. Well, real numbers, I'll just even draw this up here. You don't even have to put this down. Whenever you make a real number line, anything that's on this real number line, we have 0 here, we have 1, we have 2, we have all the positive whole numbers. Here we have -1, and then we have -2. We have, as we go to the left, all the negative numbers. Well, any number in between all these, like here, here, even if it's decimals and fractions, they're real numbers. So basically, any number is a real number. Okay, now when we start to kind of distinguish and we start to narrow the type of numbers down, rational numbers, okay, for number 2, if you look in it, the word that's within rational numbers is the word ratio. Okay, this is any number that can be written as a ratio. There's many examples. Now, any whole number is a ratio. You might say, here's an example, 3. You might say, well, that's not a whole number. It's not written as a fraction. But 3 is the same as 3 over 1. And then you could write any fraction, because a fraction is a ratio. I could put 1/2, I could put 2/3, and so on. I can keep going. Now, irrational numbers, not many numbers are irrational. Now, this just means the opposite. This is any number that cannot be written as a ratio. The most famous example is pi. Okay? And another way of stating this, irrational, I know it's 3.14, I think like 59, and it keeps going. Here's why it's also irrational. Because it's a decimal, and the decimal doesn't repeat. It keeps going on forever, and there's no pattern to it. Okay, like if I gave you, I'm going to give you an example of a rational number. Let's go 1/3. Okay, that, if you put 1 divided by 3 in your calculator, is 0.3 repeating. Now, even though this doesn't end, there's a pattern to it. Here, there's no pattern to it. That's why it's called irrational. If there's, no pattern to anyone's behavior, we say they're acting irrational. So that's what it kind of means when we look at the math terms there. Okay, the natural numbers, this is basically just all your positive whole numbers. And our first positive whole number is 1. Another name for this is we call it the counting numbers, because when you count, you always start with the number 1. So, natural numbers, these are just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we keep going, all the way to positive infinity. Now, whole numbers, this is almost the same thing, except we have 0. Now, when you count, you don't start with 0, you always start with 1. So, there's the difference. Natural numbers, I said, is counting numbers, so this, whole numbers, is almost the same exact thing, except we include 0. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we keep going to positive infinity. Okay, integers, we're just getting more whole numbers. We're including everything. All positive whole numbers, all negative whole numbers, and then also 0. So if I want to do this, we're going to go both ways. I'm going to put dot, dot, dot. I'm going to go -3, -2, -1, 0, 1, 2, 3, and I keep going. So this dot here means, if you've ever seen this sideways figure 8, that means infinity. If I put a negative in front of it, this means negative infinity. Alright, so this is everything that we're dealing with as far as the types of number sets that we work with. Most numbers are rational. There really aren't too many cases where you have an irrational number. The one case is pi. We'll also look at examples when you take square root. So basically, if you get a long, ugly decimal and there's no pattern to it, we say it's irrational. Now, if I kind of did, I guess sort of like a Venn diagram, I'm going to erase this right here. If you can find space maybe on the top, I'm going to draw like a little picture here that kind of will help us remember the number sets. I'm going to do this. I'm going to draw a big square right here. And then everything in this square is all real numbers. So any number on the real number line. Now I'm going to draw a circle. And basically real numbers are split into either rational numbers, so put RATL, or irrational. So put IRR for irrational. Then all these other ones, the natural numbers, the whole numbers, and the integers, well, they can all be written as a fraction or as a ratio. So they're all rational. So I'll put in here, let's see here, the one with the most is the integers. So I'm going to put in here integers. I'm going to put INT. Then after that, then we have whole numbers. So I'll put W for whole numbers. And then I'm going to put this N right here. That's the natural numbers because it doesn't include 0. Alright, hopefully that makes sense to you. Like I said, most cases, most numbers are rational. Alright, let's look at some examples right here. The examples are pretty quick to tell. Alright, we just want to find what each number or fraction, what it belongs to, which of these sets. Some of them, maybe only one of them, or maybe 3 or 4 of them. Okay, 5 over 22. Now, first of all, it's written as a fraction, so it's a ratio. So I'm going to say this is a rational number. Let's look. It's not a whole number, so it can't be a natural number, a whole number, or an integer. So that's it. Okay, now this square root of 81. If you put this in your calculator, square root of 81 gives us the number 9. Alright, so 9, I know you can write that as a fraction. You can write that as 9 over 1. So this is rational. Now it's a whole number. It's also a natural number because it's a positive whole number. And then obviously it's a whole number. And it's also an integer. Now square root, I didn't give the definition of this. We'll probably do more work with this later in the year. This basically asks you what number times itself gives you 81. Well, 9 does. If you didn't know that, just throw it in your calculator. Okay, if you did square root of 56, if you did that, okay, you put square root of 56 on your calculator, you get a long, ugly decimal. It's like 7.483314774. Now, if you look, this is a long, ugly decimal, and it keeps going. I'll put little dots there. There's no end to it, so it looks like pi, and there's no pattern to it. 483314774. There's no way that you could even predict what the next number is. So we say this is irrational. And then if it's irrational, that's it. Remember, most numbers are not irrational. So if it's irrational, then it can't be rational, and it can't be all the other ones, natural number, a whole number, or an integer. Okay, next one we have is 0. We can write this as 0 over 1, so this is obviously rational. It's not a natural number because natural numbers are just positive whole numbers, but this is a whole number because that includes 0, and it's an integer because integers include 0. Okay, negative 9 over 2. Obviously, it's written as a fraction or a ratio, so it's rational. Then if we look, let's see here. It can't be natural, a whole, or an integer because this, as a decimal, is negative 4.5, so it's not a whole number. So it's got to be at least a whole number to be a natural number, a whole number, or an integer. So that's it. Okay, then if we did 14 over 2, well, 14 divided by 2 is just 7. And you could write 7 as 7 over 1, so this is rational. It is a positive whole number, so it's a natural number. Then let's see, it's a whole number, and then it's also an integer. Okay, so that's all you're doing with that. Okay, let's move to the second page. Let's finish that part up. Alright, the second one right here, this is where we're going to graph this on a real number line, and we're going to order the numbers from least to greatest. You can use your calculator, whether it's a TI Nspire or a TI 30, and we can put this in. And probably the good thing to do is with some of these is make them decimals, because it's really easy to work with decimals. Now, number 7, we actually, oops, little crooked there, I'll get rid of that. With number 7, we can kind of leave them as they are because they have the same denominator. We know if we had, let's say this is 0, let's make this, let's see here, let's make this 1, let's make this 2, we'll go -1 and -2. Okay, if we had, let's see here, -1/3, well, -1/3 is going to be right about here. Okay, it's a third of the way between -1 and 0. Now I want to take care of the negatives first. -4/3, well, that's the same as if you wrote this as a mixed number, -1 and 1/3. So that's going to be a third of the way between -1 and -2. So I'll put -4/3. Okay, so I'm done with these. The negatives, I cross them out. This 2/3, well, that's 2/3 of the way between 0 and 1, so it's going to make it a little bit closer to 1, so that's 2/3. And then, across that, this 5/3, well, if I wrote that as a mixed number, that's 1 and 2/3. So that means that's 2/3 of the way between 1 and 2, so it's right here. So this is 5/3. All right. Okay, I'm just going to erase some of this, so you can even pause it right now. Make sure you have this. Okay, I'm going to erase it and put a new number line for number 8. Okay, number 8, I see we have some square roots in there. Break out your calculator right now. I'll put this in the middle. Okay. Let's see here. 6 4/5. I would put 4/5 in your calculator. If you do that, you get 0.8. So this is 6.8. Okay, the 49, well, that's just 7, square root of 49. And then 6.3 repeating. I'm just going to kind of write this out a little bit. 6.33333. And then if you did square root of 39, I'm going to put this in my calculator right now. Whoops. Second square root of 39. And this gives us 6.2449. And now I know from looking at it, the smallest one is this. So if I graph this, look like I'm just dealing with 6 and 7. I'm just going to put 6. I'm going to put 7. So this is really close to 6. So I'm going to put square root of 39. So I'm done with that. I'm done with this. Okay, then this 3 is less than that 8. So this goes next. So it's 6.3 repeating. So it's like right about there. Put 6.3 repeating. Okay, I'm done with that. And then obviously 6.8 is less than 7. So this is real close to 7. I'll put 6 4/5. So I'm done with this. And then, well, this is the biggest number right there. So I just plot this right here. And I'm just going to put in parentheses, this is also the square root of 49. Okay. Now the one thing I didn't do for the last one, let's put these numbers in order. And to put them in order, I just read this left to right. So if I read this left to right, this was the first one, which was the square root of 39. Okay, this is the second one, which is the 6.3 repeating. Then this is the third, so it's 6 4/5. And this is the last to the right, so that's the biggest number, which is 7. So a lot of this is just kind of going over number sense right here. Yeah, we would love to deal with whole numbers all day, but you're going to have some fractions. You're going to have some square roots that give you some long, ugly decimals. We really have to have sense of where it lies. Which two whole numbers does it lie in between? And does it lie closer to 6 or does it lie closer to 7?